Hi there, I'm Mr. Orr, and we are back again to look at section 7.2 in your algebra textbooks, which is working with properties of exponents. So here we have a problem we're going to take a look at. This looks like a complicated problem, and there are some twists and turns to it, but you'll see how it works when we break it down into pieces. Now, the first thing we're going to do, there are different ways you could approach this. We could use this -2 and multiply it. Here we have all these exponents, so we could multiply. So we get -3 to the -2 power, 6 to the positive 2, y to the, positive 12, y to the positive 2, z to the positive 4, etc. I'm going to show you a little trick that will make this problem a little easier because we have numbers here. And those tend to confuse things just a little bit. You can do it this way, but my recommendation is let's make use of this negative sign right here and use it to flip the entire thing upside down. Because remember, that's what we do to make a negative exponent into a positive one. We flip the fraction over. So what I'm going to do is take all of these exactly as they are and put them as the numerator. I get 6x to the -2, y, z to the -5, over -3, x to the -6, y to the -1, z to the -2, and all that is now, because I flipped it over, all that is now to the positive 2 power. Okay, now from here, we can either simplify inside and then apply this exponent, or we can apply the exponent and then simplify inside. Let's this time try simplifying inside first. So, recognizing that I'm going to have on the outside of this fraction a 2 right here. Let's look on the inside. 6 divided by -3 is -2. X to the -2 over x to the -6 is -2 minus -6, which is -2 plus 6, which is 4. So I have a positive 4, therefore it goes here. All right, I have a y here, which is to the first. 1 minus -1 is 1 plus 1, which is 2. So I have a y squared here. And the third one is -5 plus 2 is -3. Therefore, it's negative, it has to go underneath as a positive. So if I'd put it up here, it would have been z to the -3, but it's much better to have it go underneath and become positive. All right? So underneath here we have a z to, I have it there, z to the third. Now, everything's done except for this exponent. And to do that, we're going to square everything inside here. -2 squares to become 4. X, 4 times 2 to the 8th, y to the 2 times 2, or 4, z to the 2 times 3, or 6. And there's no further canceling you can do. Actually, we don't even need those parentheses. So that's how this problem works. Let's take another problem of a little different nature. And let me see if I can find one here that suits my purposes. How about this one? 2a squared b to the third, 2a squared b to the third. Let me see here. Where did it go? Here we go. C to the -5 over 10 to the, let's see, a to the -3, b to the -1, a to the -3, b to the -1, c to the -4. All right, now, we don't have an exponent on the outside, so that simplifies the problem. 2 over 10 is 1 over 5. A to the 2 minus -3 is a to, now, let me show you two ways to do this time. 2 minus -3 is 2 plus 3, which is 5, a to the 5th. I could also have said, this is negative. To make it a positive exponent, I have to bring it up above the line. Then it becomes a to the 3rd times a to the 2nd. You add the exponents, you get a to the 5th. Different methods, same result. All right, let's do that method with this one. This comes up here, becomes a positive 1 to join with this b to the 3rd, which makes b to the fourth. I could also have said 3 minus negative 1 is 3 plus 1, which is 4. All right. Now these two, negative 5 minus negative 4 is negative 5 plus 4, which is negative 1. Let's do this though. In this case, let's bring this underneath and this one up above. Because remember, if you flip it, the exponent becomes positive. That gives us a c to the fourth up here and a c to the fifth down below. Okay? Now, either 4 minus 5 is negative 1, which would give me a c to the negative 1 here, but I want it underneath as a positive, so I could move it and make it c to the 1. Or I could start here. 5 minus 4 is 1, but it goes underneath because the bigger number was underneath. Okay, there are a number of different ways to approach these problems. I'm showing you a few of them. You can choose the method that works best for you. If we had done minus 5 minus negative 4, we would have had minus 5 plus 4, which is negative 1. I would have had c to the negative 1 here, which I then would have moved down here to make c to the positive 1. All right? Again, different approaches. Take your choice, but the rules all apply in the same way. All right, let's stop there for this video, and I may come back and give you one more video with another one of these fairly complicated problems here. By the way, some of these problems, you have a complicated set of x's and y's with exponents inside and maybe some numbers, and you'll see a 0 out here. Don't do all the work inside, because anything to the 0 power except 0 is 1. So in fact, for the most part, these are going to come out to be 1, even with all the complications inside. The only thing you would have to be careful about, I think, is if this came out to be 0, because then 0 to the 0 power is undefined. Typically, I've not seen those occur in our textbook. All right, I will see you next time.